Welcome back, Algebra 2 students. Today we are working on day 6 notes. Our goal is to be able to evaluate logarithms with exact values. So when we think about these logarithms, we're going to remember that we can use our converting process. So we're going to take our logarithm and we're going to think log base 4 over 64 is equal to what? And I'm going to think of this as like a question mark. Okay? And I'm going to use what we did yesterday and convert this logarithm into exponential form. So my base on the logarithm is 4. And so really I'm saying 4 to what power will give me 64? And 4 to the third power will give me 64, so the simplification of this is 3. Okay, let's try this again. So log base 5 of 625 is equal to what? All right, so I'm doing 5 to what power? I'm going to start representing that with a variable instead of just a question mark. So 5 to what power will give me 625? And this one's a little bit bigger, so if you need to grab your calculator, totally okay. Go ahead and try 5 to different powers. When you start doing 5 to different powers, you should be seeing, let's try this. I get 5 to the third power is 125, and 5 to the fourth power is 625. So 5 to the fourth, x has to be 4. Okay, we get a little bit more complicated here because now we've got log base 6 of 1 over 216. Okay, and so now I'm asking myself 6 to what power will give me 1 over 216? And now I have to remember my properties of exponents here. In order to end up with division, I'm going to need a negative exponent. So I'm going to work on my calculator showing me negative exponents. Let me extend this guy out a little bit so you guys can see the whole thing here. Okay, so let's do, I wanted 6 to some power, so let's do 6 to, well, I know the second power is going to be 36, so let's try 6 to the negative third power. And that's not, I don't know what the heck that is, right? So math, enter to see if that is, that's 1 over 216, perfect. All right, so 6 to the negative third power will give me 1 over 216. Log base 12 of 12. Go ahead and try this one before I finish it. We'll write it in exponential form. 12 to what power is equal to 12? Hopefully that's a no-brainer. You're getting 1. This one, I think, I like number 5 a lot. 13 to what power will give us 1? We have to remember those properties of exponents. And if you remember, if I want to get 1, raising anything to the 0 power will give me 1. So 13 to the 0 power will give me 1. Log, what the heck is the base here? There's no there's no number written underneath there. There's always a base on the logarithm. In the United States, we use a base system of 10. Thinking about money, right? You move the decimal place over one, every time you move the decimal place over one place, that's multiplying by 10. Okay, so we're going to assume that if we don't see a base on a logarithm, that the base there is 10. So this is equivalent to writing log base 10 of 1 over 100. So we're rewriting this as 10 to what power would give me 1 over 100? Well, 10 to the second power would give me a 100. To make that a negative exponent, I'm saying negative 2. Or sorry, to make that 1 over 100, I'm saying negative 2. Go ahead and try 7 and 8 on your own. Go ahead and pause the video. All right, 6 to what power would give me 1 over 6? Hopefully you're getting negative 1. 14 to what power would give me 1 over 196? Hopefully you're getting negative 2 there. There's one more problem I want to address. It's not on here at all. Okay, but I want to do log base 3 of negative 9. Okay, so log base 3 of negative 9. Again, we're going to rewrite this in exponential form. 3 to what power would give me negative 9? Okay, well, I want to think about this. 3 to the second power would give me 9, but how on earth do I get negative 9? And I'm going to realize really quickly that I won't get negative 9 out of this, right? Because I'm repeatedly multiplying 3. If I repeatedly multiply a positive number, the result will be a positive number. So anytime that the term of my logarithm is negative, my overall simplification is actually going to be undefined, right? Because when I raise a positive number to any power, I will always end up with a positive result. All right, that's it. I'm going to let you guys go ahead and start your practice.